Okay, here are the answers to question number 6. Question number 1. You could get the current through 12 ohms in two ways. First, if you look at the potential difference between A and B, it's just going to be 3 volt, because you have 9 volts here and you have 6 there. So the potential difference of voltage between A and B is going to be 3. So to get the current through 12 ohms, just got to divide 3 by 12, which gives you 0.25 ampere. Or the second method is to apply Kirchhoff's loop rule in the two loops. In the top loop, I've done it in the bottom loop first. In the bottom loop here, negative 18 I2 plus 9 is 0. That gives I2 0.5. And then in the top loop, going counterclockwise, you have negative 18 I2, negative 12 I1 plus 6 is equal to 0. Then substitute the value of I2 and solve. You would once again get I1 as 0.25 ampere. Question 2. You have two resistors, 5 ohms and 9 ohms, connected in parallel like that. And then you have a 4 ohm resistor connected in series to that. You're asked to find the current through the 9 ohm. Okay. First take the equivalent resistance of 5 and 9, which would be 3.21, and then add it with 4, that gives 7.2. Then you find the current, which is 0.83 ampere. Okay, and that current flowing through the parallel combination produces a voltage, which is the current multiplied by 3.2, because that's the parallel combination. So you get 2.67 volt, right? And so the current through the 9 ohms would be 2.67 divided by 9, which is 0.30 ampere. If you were asked to find the current through 5 ohms, it would be 2.67 divided by 5. So that's how you do this question. In this question, there are 3 capacitors connected in series, and you know that the equivalent capacitance is given by this formula. That's what you get when you calculate. And on taking the reciprocal, you get 3.125 microfarad. And the charge is that capacitance multiplied by the voltage, which gives 37.5 microcoulomb. Remember that the charge through each one of these 3 will be the same because they are connected in series. In this question, the discharge of a capacitor through a resistance is given by that equation. Divide both by capacitance, both sides in fact, and that makes it in terms of voltage. And then the given voltage is 3 divided by the maximum 12. As long as you have 2 in microfarad and the other one, you see microfarad is 10 to the negative 6, and then you have 10 to the negative 6 there and 10 to the positive 6 there. So they simply cancel out and you get 2 times 4 is 8. So when you do the calculations, get the time as 8 times natural log of 4, which gives 11 seconds. In this question, in this question it's pretty straightforward. What is the potential of A relative to point C? Surely 6 volts. No need of any calculation. Look at the diagram carefully. C is connected to the negative point of the battery and A is connected to the positive, so the potential difference between A and C is simply 6 volt. Now in this question, 2 resistors, 15 and 30 ohm. This is just like a previous question that we had done. So what you do is find the parallel combination first, product by sum, and then add that to the one in series with that, which is 20. So you get 30 ohms, and then find the current. Well, before you find the voltage, you have to find the current. So the current is 9 volt divided by 30, and now the voltage across only the parallel combination is that current multiplied by 10. And how to find the currents through that? Just divide 10 by 15, you get the current through the 15 ohms. And if you divide 10 by 30, you're going to get the current through 30 ohms. Here, the currents are equal through that. I'm sorry, that is a parallel combination, so the currents are not equal. The voltage is 36 volt against both, so to find the current through 6, all you got to do is 36 divided by 6. That gives you 6 ampere, and power is I squared times R. So 6 squared times 6, that gives you 216 watts. This one, 100 watt light bulb connected to 120 volts. So find the current required by each one, which is simply by using P is equal to the product of voltage and current. So each light bulb requires 5 by 6 ampere, and let's assume there are n such light bulbs. So the total current required by these should be n times 5 by 6, which should be equal to 20, because it cannot be more than 20. And then you get 24 as the maximum number of light bulbs, so that the 20 amps circuit breaker doesn't trip. This circuit, if you look at it carefully, you have the 220 ohms in parallel, so that'll give you 10 ohms. If they're equal, just divided by 2. And then you have the 30 and the 10 in series with that, so you add all those, get 50 ohms. And you find the current by 40 divided by this, which is 0.8 ampere. And then multiply that current with that resistance, 10 ohms, so you get the voltage. It's 8 volt. And on the last one, here it's a series combination. Same current flows through both, and you want to find the voltage drop across the 3 ohm. All you got to do is multiply the given current, which is 14 ampere, with the resistance, which is 3 ohms. So you get 14 times 3, that's 42 volt. And similarly, the voltage drop across the 4 ohm would definitely be 14 times 4, which is what, 56 volt. Thank you. I hope you definitely understood all these questions. Thank you so much.